slightly different from what we have done till now, right? Slightly different. I'll take this caselet a little later. I'll take this one a little later. It'll take some time. But before that, I will move to another caselet, which happens to be a little different, but it's nice. It's like a game. It's like a question on games, right? And I hope you guys can see the data. It's I've tried to place all the questions in one thing, but right, just see for a minute, and then I will push it to the next slide where we'll take question by question. This is where we'll be solving it, right? So just try to read. There are some biscuits placed in front. Okay, that's what you're planning to read. Let me give you about 1 minute time. Okay, are we good? Nice, no? Interesting one. There's some kind of a game. There's some biscuits. Okay, there's some biscuits placed in front of them. I'm not sure what they do with the biscuits, but alternately they pick one, two, or three biscuits at a time. The person picking the last biscuit loses the game. Passing turns was not allowed, and though it was just a game, both play to win. So this normally we call it as an intelligent game, right? What is an intelligent game? Everyone plays to win. That means you're not trying to give up on the game. You know that as far as possible you want to win the game. Second, in an intelligent game, you cannot hope for the other person to make mistakes, right? The other person is not necessarily making mistakes. So what do you think the answer is, guys? Let's do this question, okay? Now, what do you think the answer is, right? For the first question, if there are 198, 199 biscuits, what should be the minimum number of biscuits Bhaskar should pick in order to force a win over Askar, given Bhaskar begins the game? Mm-hmm. Okay, good. I see lot of answers coming, right? Mm-hmm. Let's see what we can do here. Okay, the first thing what we need to do is we can identify with this question easily. That's a games and tournament type question, right? It's a game type question. We can identify the question easily using something again that we have been using today. That's MI, or the mathematical induction. Wherein our aim is not really to find till 198. We'll try till some steps like we have done in the previous previous questions. We'll try till some stage and see where we can extend the logic to a larger level. Okay, so let's begin. So let's take, for the sake of assumption, I'll say, there are two guys, uh, Asghar and Bhaskar. So let's assume that Bhaskar begins the game, right? And the number of biscuits in front of them, let's call it n. Number of biscuits is n. Bhaskar is the first person. Whatever the number Bhaskar picks up, then Asghar whatever he picks up, what is remaining, and what is the condition, whether who is the winner, whether Bhaskar or Asghar. Now we understood one thing, that alternately they have to pick up. They cannot pass a turn, right? They have to pick up 1, 2, or 3. And the person picking the last loses the game. So pretty simple. Let's try to work it out quickly. Let's say there is one biscuit, and the person who begins is Bhaskar. So when Bhaskar has only one biscuit, he cannot pass a turn. So Bhaskar has to pick this. How much is remaining? 0. So the winner will not be Bhaskar. The winner will be Asghar, though Asghar has not even made an attempt, because the last biscuit was picked up by Bhaskar. Whoever picks up the last is a loser. If there are two biscuits and Bhaskar and Asghar play intelligently, Bhaskar will pick how many? Of course, Bhaskar will pick 1. Why? So that 1 is remaining. That remaining 1 will be picked up by Asghar, and the winner would automatically be Bhaskar. Right? What if there are 3? The same logic. Bhaskar would pick 2 because he has the choice of picking 1, 2, or 3. He would leave 1 for Asghar to pick, and the winner would still be Bhaskar. Suppose there are 4, Bhaskar would pick 3, the remaining would be 1, and Bhaskar would still be the winner. But if there are 5, there are 3 choices now. Bhaskar can pick 1, 2, or 3. If Bhaskar picks 1, Asghar is realized, or Asghar already knows, that he has 4 with him. So Asghar would pick up 3, so that 1 is remaining. Please understand, this 1 remaining is for Bhaskar, not for Asghar. If Bhaskar picks up 2 in the first go, then there are 3 left. So Asghar would automatically pick up 2, so that 1 is remaining for Bhaskar. If 1 is remaining for Bhaskar, Bhaskar had no choice but to pick that 1 and lose. If Bhaskar picks up 3, Asghar would eventually pick up 1, so that there's 1 remaining, and Bhaskar will have to end up picking that. Which means, come what may, in all the 3 cases, the winner is Asghar. Right? So it's pretty nice, pretty cool. And if we extend the game, Bhaskar, Asghar remaining, and winner, if there are 6 biscuits, now Bhaskar has learned a trick that whoever has 5, it does not matter whoever starts with 5, and whatever they play, they'll end up losing the game. So Bhaskar would pick up 1, so that there are 5 remaining, and the winner would definitely be Bhaskar. If there are 7, Bhaskar would pick up 2, so that there are 5 remaining, and the winner will be Bhaskar. If there are 8 remaining, Bhaskar would pick up 3, and there are 5 remaining, and the winner would still be Bhaskar. But if there are 9, now that's again where the catch happens. It could be 1, 2, and 3, because there is 8 left for Asghar. Asghar will pick up 3, so that 5 is left finally for Bhaskar. The winner would be Asghar. Why? For the simple reason that after which this will be the cycle followed. If there is 2 picked up by Bhaskar, Asghar will pick up 2, so that 5 is remaining for Bhaskar, and then this cycle of Bhaskar will follow. And if Bhaskar picks up 2, Asghar will pick up 1, so that 5 is remaining for Bhaskar, and exactly this cycle will be followed. It does not matter what. At 5 biscuits, Bhaskar would end up losing. That means in all the 3 conditions, the winner is Asghar. So we notice some, can you look at the summary of this, right? If there are 10, this one will pick up 1, so that 9 remaining, right? Bhaskar is the winner. If there is 11, this one will pick up 2, so that there is 9 remaining, winner is Bhaskar. If there are 12, he'll pick up 3, so that there are 9 remaining, and the winner is Bhaskar. But if there is 13, then he cannot pick up 4, right? So if that logic is fine, shall we move? All of you? Good? So now the logic is consistent. The person who started with 1 biscuit loses. The person who started with 5 biscuit loses. The person who started with 9 loses. We found 13 loses. You notice this difference happens to be 4. That means the person who picks up 17 and 21 and 25, etc., this would definitely lose. In fact, the difference is 4. So we know what is arithmetic progression. We can say each of these numbers is a condition for a loser. This number, we are talking of this number 1, 3, 1, 5, 9, 13, 17, 21. This is a condition for a loser, right? But you see the difference is 4. That means the next number that we want after 21, instead of just adding 4, we can simply say the number can be given as 4 into n plus 1. Now this is the condition for loser, and anything besides this is the winner. Okay, for example, someone started with 65. Now 65 is of the format 4 into 16 plus 1. Certainly the person will lose, because if the person picks up 3, the other person will pick up 1. So the next stage the person is 64. Why? 4 less. And if the person picks up 2, the other person will pick up 2. So that the first person ends up having 57, which is again of the format 4 and plus 1, and so on. Right? Are we okay? But what you should notice is something beyond this. What you should also be noticing is this, that this 4 and plus 1, from where did we arrive this 4? How did this 4 come? Why shouldn't it be 5 and plus 1 or 5 and plus 2? You'll notice that it is always possible to create a number 4, but it's not necessarily possible to create a number 5 or 3. Let me give you an illustration of what I'm saying. Suppose B and A are the two persons who are picking, and B picks up 1. A can pick up 3. 4 is done, right, in one cycle. If B picks up 2, A can pick up 2. 4 is done in one cycle. If B picks up 3, A can pick up 1. 4 is done in one cycle. Let's take the same thing for 5. If B picks up 1, what will A do to ensure that 5 is getting over and around? A has no choice. A can pick 1, 2 or 3. But 3 plus 1 is not 5, 2 plus 1 is not 5, 1 plus 1 is definitely not 5. Yeah, it is possible if B picks up 2 and then A would pick up 3. What if B picks up 3, A can pick up 2? But is this possible? B can also pick 1. Likewise, is 3 always likely? What if B picks up 3? A cannot pick a 0. Not allowed. Right? And just not allowed. A cannot pick 1, A cannot pick 2, A cannot pick 3. What's this? Nothing is allowed. But 4 is always allowed in this case. That's why it became of the format 4 and plus 1. Which means, essentially, if I am saying, now the case is now changed. Instead of picking 1, 2 or 3, the game was changed to 1, 2, 3, 4, 5 biscuits. You can pick one among these, 1, 2, 3, 4, 5 biscuits. Now what will the game change? Which number is definitely allowed? You notice the number that is definitely allowed is 6. Why? If one picks 1, one picks 5, the other will pick 1. If one picks 4, the other can pick 2. If one picks 3, the other can pick 3. That means 6 is always allowed. Is 5 necessarily allowed? No. What if one person picks 5, the other person cannot pick 0? Is 7 definitely allowed? What if one person picks up, 1, the other person cannot pick 6, right? That's not allowed. But 6 is always allowed. So in this condition, the loser condition will simply become 6, that is this plus this, or this plus this, or this into 2. So you saw the 3 cases. That is 6 and plus 1 will be the loser if we change the question to something like this, right? So that makes a lot of sense, right? How we can. So now let's look at the question. Honestly, let's look back at the question and say there are 199 biscuits. Then what should be the number of biscuits Bhaskar should pick in order to force a win over Askar? We know 199 is nearer to 4 and plus 1 format. The nearest number to 4 and plus 1 is 4 into 49 plus 1. 4 into 49 is 196 plus 1, that is 197. And 4 into 50 plus 1, that is 200 plus 1, that is 201. So what it means is, if Bhaskar ensures that Askar gets either 197, right, or 201. 201 is out of context. You cannot give biscuits, right? You cannot contribute to biscuits. You can reduce the biscuits by picking them, right? If he picks up some number of biscuits, let's say he picks up how many biscuits from 199, the number boils down to 197. That's pretty simple. He will pick up 2. But note this, at every stage, this number has to be of the format 4n plus 1. That means, let's say Bhaskar picked up 2 and Askar now picked up 3, so Bhaskar has picked up 1. So that left is 193 and then left is 189. And this will reduce by 444 every time. This will reduce by 4 every time, right? So that's the logic. That means the winner of the game is 4n plus 1. There's another way to interpret this. If we take a number like 199 and we divide it with 4, what is the remainder? The remainder happens to be 3. That means you don't lose. If the remainder happens to be 1, you will lose. If the remainder happens to be 2, you don't lose. If the remainder happens to be 1, you will lose. Example, if we take the number 69, if we divide with 4, the remainder happens to be 1. So you will lose. So this concept of 4n plus 1 is pretty similar to remainders as well, right? Are we all on the same page? Super, right? So let's look up the next question. The same logic. What natural number what if n is a natural number, then what option makes the beginner of the game the loser every time? If you take 5 divided with 4, what is the remainder, guys? Right? 5 by 4 remainder is 1. Right? We understand 5 by 4, the remainder is 1. What's 5 square by 4? The remainder. We all understand 5 into 5, 25. 25 divided by 4, the remainder is 1. Right? Or we can also write it this way. If I have a number divided by d, the remainder is r. The number power a divided by d, the remainder is r power a. Right? So with the same logic, we can say, hey, okay, that 5 cube by 4, the remainder is going to be simply 1 cube. That's going to be 1. So every time the remainder is 1, that means with 5, you'll automatically lose the game. Cool? But that does not answer the question, because 17 divided by 4, the remainder is again 1. Right? 17 by 4 also the remainder is 1. And 17 square by 4, the remainder is 1. 17 cube by 4, the remainder is 1. And 17 power 5 divided by 4, the remainder is 1. And this will always remain 1. That means this is also true. And if this first A and B are true, that means C will necessarily be true. In fact, all of this has to be true, right? It cannot be separately A and B are true, and two answers cannot be right in the same question. So all of them will be true. Of course, this question can be tweaked. Now, how you got to start thinking on this question? It's not just this question. What you got to think next is, what if there are 3 players, right? What if there are 3 players? What if there are even number of picking? Where you can, it's not that 1, 2. You cannot pick 1, 2, 3. What if you're allowed to pick up only, uh, you got only 1, 2 and 3. Let's make it 2, 4 and 8. What if we had some option like that? But that's exactly what you start thinking on. That's how you build the thinking process, right? Is it something that will come in CAT? I'm not sure, but it is something that will help you think better in CAT. That's for sure. That's exactly what you want to start doing in this question, right? So let's go to another set. Are we all okay? You need a break. Let's say a 5-second break. Is that okay? Yeah. So 1, 2, 3, 4, 5. Okay, let's give you another 5-second break. We'll go to the next question. That will be an intriguing question again. I hope so. Right? It's as intriguing as what we have done till now. So what we'll do is, like we've built some logic in the first caselet, the first caselet that we did today. That the first question that we did rings. So here we were trying to build a logic. The next thing I'm going to do is on data arrangement. Now, again on data arrangement, we'll try to build a step-by-step approach. But guys, this is not the highest level of data arrangement we're going to take. By the time we come to the, maybe midway or towards the end of these sessions, you'll see data arrangement can be taken to a logically higher level. And we'll come to that. So what we'll do is, the next thing we're going to do is some questions on data arrangement. We'll start with one very simple question, which is an old cat question, right? And I'll give you a minute's time to just, not a minute, a few 10, 15, 20 seconds maybe to read it. And there is a question based on it, right? The question is, which of the following statement is true, right? That's a pretty simple question, but yeah, it's a data arrangement question, one question, right? Single question, and from here we'll build a process. We know the table method, so we'll use the table method, and you'll see how I progressively change track. Okay, so take your half minutes time. Please read it up. Banerjee Sharma. Banerjee Sharma. Ninth. I have not done for 6. Slow. Okay, that's cool. So let's do this question. Simple one. The Banerjee Sharmas will use the tabular method. All of us are familiar with tabular method. We've used it while we were doing this caselet. I'm hoping that you guys remember the caselet that we were discussing last time. We were doing this caselet of Amit, Avinash, and Sureka, and Sonal, and so on. Right? Similar caselet. So let's take this now. We'll put the family names, and here it's a very simple caselet. So honestly, you don't even have to worry which is coming first, which is coming second. There's no pivotal column here for the simple reason that it does not matter. It's so simple. So let's put family. Let's put the name of the dish that is served. Let's put the color of their chinaware and the type. The name of the families are Sharma. We have the Banerjee and the Pattabi Raman. Okay, the Sharma eat at noon, that's at 12. The family that serves fried brinjal uses blue chinaware. So this is outside the table, we can't help it, right? So the dish is brinjal, that is blue chinaware, right? The Banerjee eats at 2. The family that serves sambar does not eat red. Sambar is not red. Negation, right? Sambar is not red. The family that eats at 1 o'clock. So 1 o'clock we have only one family left, right? 12 o'clock is Sharma, Banerjee is 2 o'clock, so Patabi Raman should have at 1. That's straightforward. So the family that eats at 1 o'clock serve fried brinjal, right? At 1 o'clock served fried brinjal. So this Patabi Ramans have to be brinjal and in blue chinaware, right? The Patabi Raman does not use white. We already know it is blue, so this detail is not required. In fact, many times they give questions, specifically in ZAT, which of the following statements is not even required to answer the question, or how many of the following statements is not required to answer the question. That could be another way of attempting these questions. Okay, right. But let's get back. Let's get back to the question. The family that eats last has makki ki roti, right? So makki ki roti, that is a Banerjee. They eat last. So we know there's only one item left, that is sambar. The dish has to be sambar, and sambar is not red, so makki roti is red. And we have one more color which is white, so sambar is white. It's pretty simple. Now, if you look at the table, it's simple. At 12 o'clock, the Sharmas have food, and they have sambar in the white chinaware. At 2 o'clock, the Banerjee have food, that is makki ki roti in a red chinaware, and at 1 o'clock, the Patabi Ramans have brinjal blue chinaware. It's a pretty simple caselet. It's so easy that we have done something similar. Which of the following statement is true? The Banerjees eat makki ki roti. That's right. At 2 o'clock, that's right. The Sharmas eat fried brinjal. Right? No, the Sharmas actually have sambar, right? So that's not right. So let's go to the statement B. The Sharmas eat sambar served in white chinaware. You'll notice that is it's white. That's fine. Patabi Ramans eat brinjal at 1 o'clock. Patabi Ramans eat brinjal at 1 o'clock. That's fine. and the Banerjees eat roti in blue Chinaware. That's wrong. But you can check the last third one. You'll see that everything is absolutely right. The Sharmas eat sambar at noon. The Pattabi Ramans eat fried brinjal served in blue Chinaware. That's also correct, right? And the Banerjees eat makki ki roti in a red Chinaware. Everything sounds good. So that's how easy this caselet is. Okay, so just building the platform. Now we'll take the next one, right? If you're done with this one, this concept, we are building the concept of a table. Very good. Okay, very easy. Also the table, the pivotal column that I told you, the concept we are working in the last class, that may help sometimes in reducing some effort. However, for now, I want to change the entire thing, right? We will take this data and we'll try to do this question in a totally different format, which will take us a lot of time, which might end up taking a lot of time, but is another foolproof method. Is another foolproof method, right? So three men were wearing. Okay, you can take about 15-20 seconds to read that, and then we can answer, or maybe about 30 seconds, 1 minute.
Press the bell icon on the YouTube app and never miss another update.
Okay. Are you guys good? Okay, I think we should start. We shall start. Let's see. Let's see what we have to offer. So the question is talking of the names Ganesh, Jagan, Lakshman. What we'll do is, for a change, we'll do something incredibly different. And at times, a lot of people have asked me, why even bother to do this method? Like I said, if you want something foolproof, you'll have to take up the pain, right? So this is a little painful method, I agree at times, but it is foolproof nonetheless, right? So we will see. We will see in at the end. You'll understand why I would do this method, right? So we have drawn a grid. Okay, now I'll explain a little bit about the grid concept again, right after I finish drawing this grid for you guys. I didn't want to kill the suspense by drawing the grid at the start, right? So we have this grid, right? We have some kind of a grid. Okay, that's a very haphazard drawing that I drew. Okay, uh, so here we'll put in the names. Okay, so we have something, names with surname we have to map, names with footwear we have to map, names with colors. But the point is, what happens is sometimes the mapping may be surname to footwear, the mapping may be footwear to color, right? So what do we do, right? If such kind of, in a tableau format, only this is allowed, right? A linear one is allowed. I need a two-dimensional, mapping. What we do is, in the reverse order, we write the same thing in this direction. That means in this direction, right? We put colors and we put footwear. Now you'll notice you have names with surname, we have names with footwear, names with colors, where color with surname, we have color with footwear. You don't have to worry about this part because colors with colors you never have to map, right? We have footwear with surname. Like we have four elements: N, name, surname, footwear, color. So we'll have four C2 combinations of two each, right? Because they'll put two at a time. Yeah, they could extend it to three, but that does not matter. We have mapped it here. Everything would get mapped in a particular table like this, right? In a particular table like this. So because I need a little more space, what I'll do is I'll go to the next sheet and draw a little more broader, broader table or broader grid. This is normally called the grid. Okay, this is called the grid. You will identify with the grid here. Okay, little bigger. That's all. Little bigger here. So we can fill data in a much more better way. Or that's nothing beyond that. Okay, so we'll put the names of the people. I think we have. Let's identify the names of persons. We have Ganesh, Jagan, Lakshman. We have Ganesh. We have Jagan. We have Lakshman. Right, and here it does not matter what you put first or what you put second, because eventually it's a grid. And second thing is it's foolproof. Everything that is there in the data, that's the clues, will eventually fit this table. Right, eventually fit this table. Everything. Right, each and everything will be part of the table. Let me just take this off. Take this off. Okay, everything will fit part of the table. So we have surnames Angre, Chadda, Reddy. Let me just disguise it as you know, Angre, Chadda, Reddy. And we have type of shoes: gumboots, office shoes, sneakers. We have gumboots, office shoes, sneakers. And we have the color. I think the color is blue, brown, gray. So we'll put BL for blue, BR for brown, and we'll put gray. And like I said in the reverse, that means we'll put blue, we'll put brown, we'll put gray, and here we'll put gumboots, you'll put office shoes, and we'll put sneakers. Right? So that's a grid. So there are two types of data, like we have already discussed in the last session, on negative information and positive information. And negative information in the grid, suppose I have a grid and I'm saying I have a grid of names versus surname, right? So if I say Ganesh, Jagan, Lakshman, and Angre, Chadda, and Reddy, if I say Ganesh is not angry, that means this I put a cross here. That just it's an information what's not. But Ganesh could be Chadda or Reddy. However, if I say Jagan is angry, so what happens? Jagan becomes angry, right? Then I can cancel out the rest of the elements in that particular column. Why? Because angry and Jagan are mapped to each other. Angry cannot be Ganesh. Angry cannot be Lakshman, right? Angre cannot be Lakshman. Also, Jagan has already become Angre, means Jagan cannot be Chadda and Jagan cannot be Reddy. So you notice that when we have a positive information, if I have a positive information here, I can cancel out the rest of the row and column, right? If we have some positive information, right? If we have some positive information, let's say here we can cancel out the rest of the row and rest of that column. That means this column, that's let's say 1 2 3, row wise 1 2 3 and column wise ABC, and it's in 1C, so you can cancel out the entire row 1 and the column C. Right, are you guys getting it? Is that data cool? Right, so let's now read the data and start answering. Neither Jagan nor Reddy wore the grey gumboots, means Jagan did not wear gumboots. One data. Reddy did not wear gumboots. Second data. Neither Jagan nor Reddy. No, neither nor in English is used where? When there are two different persons, which automatically means Jagan is not Reddy. But neither of them wore what? Gumboots. And they clearly mention none of them wore what gumboots? The grey gumboots, which means gumboot color was definitely grey. So can I say the grey color object here? You'll map here. The grey, you want to map color to footwear. So color is here and footwear is here, right? Neither of them wore the grey gumboots. That means this is a tick. We can cancel out row. We can cancel out the column. Right? Are we okay with that? A tick, how does it help? But none of them wore the grey gumboots. That means they did not wear gumboots. The color of their footwear was not grey. Reddy also did not wear gumboots. Color of the footwear was not grey. Right? Is it making sense? How we are mapping this entire data? Right? Cool stuff? Okay. That's just one bit, guys. We've just done one bit of the data, right? What did we do? Neither Jagan nor Reddy wore the grey gumboots. We'll go to the second part. The sneakers were not worn by Angre, right? So the sneakers were not worn by Angre. So there's this person here. Angre did not wear sneakers. That's just a little bit of data. Let's get back. Sneakers were not worn by Angre. Lakshman was wearing office shoes. That's giving us a positive information for a change. Lakshman was wearing office shoes. That's a tick. They can cancel out that row, cancel out that column. But you notice for the row number 2, that means Jagan's row, Jagan cannot wear gumboots because office shoes is worn by this person by name Lakshman. This has to become a tick here. That means Jagan was wearing sneakers. But sneakers were not worn by Angre, so Jagan cannot be Angre. That means Jagan has to become Chadda. So cancel out row and column, right? Cancel out the rest of the row and the column, right? That also means here in this case row and column gets cancelled. Ganesh cannot wear sneakers, Ganesh cannot wear office shoes, only one left is gumboots. The row and column is already managed, but we know from here ki gumboots color is grey, so we can cancel out the rest of the row and rest of the column, right? But we know the person who wear gumboots name cannot be the name of the person who wears gumboot cannot be Jagan nor can it be Reddy. That means Ganesh cannot be Reddy because Ganesh, neither Jagan nor Reddy wore the gumboots. Reddy cannot wear gumboots. Ganesh is wearing gumboots. That means Ganesh cannot be Chadda, Ganesh cannot be Reddy, Ganesh has to be Angre, and we can cancel out the row and the column. That means you are left with Lakshman, only one surname possible, that is Reddy. So quite a lot of data, or we have almost filled that entire part that we required. We leave the last part. The footwear worn by Chadda was not brown. So who is Chadda? We know Ganesh is Angre. We know Jagan is Chadda. Jagan Chadda's footwear is not brown. It is already marked not grey. So it has to be blue. We can cancel out the row and the column and we're left with only one data. You notice we have not really solved this part. We focused on solving but we two things. We're focusing on solving whatever is there or mapping whatever is there in data, and no data went outside the table. That's the beauty of this method. However, it takes some time to draw this. But is it foolproof? 100%. 100% foolproof. In fact, in LRDI, assuming that the caselet becomes very tough, time becomes, and you're not able to solve anything, you're not able to choose anything, I would strongly recommend to take one such caselet data arrangement, a little tougher one. There's an easy one, a little tougher one, and go by this method, right? Because if you go by last year, right, even a score of 1920 would enable you to get the cutoff if the paper becomes tough. But trust me, I'm not making you prepare for last year's type situation. We're making you prepare higher than that. That means what if it becomes tougher? What to do? Does not matter, right? You got to trust us. You got to believe in what we are doing, and let me assure you that we can take you not one step but several steps ahead of where you are currently standing in LRDI. It does not matter whether you started your preparation today or you started your preparation a year back for LRDI. You're still good to go, right? So yeah, that's mapped. The entire thing is mapped, and we didn't have to fill the entire grid. The entire grid was not required by this itself. We have mapped the entire data. The rest is not really required for us. So let's answer the question. Chadda was a surname of the person wearing, right? That's simple. Chadda, excuse me, Chadda was wearing sneakers. Jagan Chadda was wearing sneakers, right? That's easy. Lakshman's surname was Reddy. It's also pretty simple, right? And yeah, more thing to notice in these caselets. It's not necessary that they have to be in order, but they may or may not become in order. So please don't say that when they mention may not be of the same order. Don't say they will not be, right? Not necessarily of the same order does not mean it cannot be in the order. You'll have to sit, solve, and then identify. These questions many times use answer options as well, right? But if you're using a grid, you don't require answer options. If you're not using a grid, you can also look at answer options to help you process the information a little faster. If you've understood these two questions and the previous question, we'd like to take you another step ahead in data arrangement. Okay, this is a little tougher question, but we have a slightly different logic that we'll figure out in this case. So I'll give you about 2 to 3 minutes to just read it, not to actually solve, to read it. We'll solve it together. Okay, we'll solve it together. By the time we are solving, if anyone gets answers, please go ahead, right? Please help us, but we'll try to do it together. We'll try to do this together, right? Okay, so take about a minute or two's time. Let's see. Okay, so that's you can start reading. Just read on the basic caselet. Okay, basic caselet and the information given, the clues. Okay, so it's a couple of minutes of reading done. Look at the clues. Okay, that's pretty important. The rest of the data is straightforward, not required. Not too much required because we have the names of these people: Buster Grant, Carrie Flynn, Errol Cooper, Gary Wayne, John Keaton, female stars, and they're not necessarily in the same order, right? So this will be slightly different from what we do. And I have christened this method as the ACE clue method. Why ACE clue? That means we're going to work on the best clue, right? So how do you identify with the best clue? Right? No one can, nor can I do in the exam. But the examiner, right, unknowingly ends up giving one, two, or max three clues which are better than the other clues. Right? That's what exactly starts happening in the exam hall. Right? You will be able to identify and within an error of one or two. Right? So you will be able to get it. Right? So let's identify we'll understand sequentially. Second, post that, what we do is we still work on the table. So we're using two methods here, two tools here to make it simplified. So we are ignoring that big table and writing a lot of data outside. We'll restrict the amount of data written outside. What we'll do is we'll use a clue, the main clue to help us. Clue number 4, clue number 5, and clue number 6. I've just named it to help you, to help you be able to connect with the clues, right? Are we all together on this? Superb. Okay, so that's quite some data. So that's the reason I want all your undivided attention on this. It'll take us a good it'll take us a good 8 to 10 minutes, but trust me, in the exam hall, once you get used to this kind of format, it should be a joke. It should be like 5, 4, 3 minutes possibly to solve this, right? Let's read this first. The first clue says the Floridian didn't make its appearance in 35 or 38. Didn't. That's a negative information. That's not really good clue. Plus, it did not star Carrie Flynn, who wasn't Garrett Lombard's star. So it's not giving us any positive information, not something that we normally like. The second one is good. Destination Phoenix or Gene Garbo. That's a positive statement. That's nice. That's good. So that could be our ace clue or the best clue, right? The third statement you read, right? The third statement says John Keaton and Carol Harlow were co-stars of the film released after the year Captain Winchester. That means these two were acting in the same movie, male star, female star, right? And the film was released after Captain Winchester. So it's telling some positive information and some extra information. Now, if you were to choose between clue 2, if you or I were to choose between 2 and 3, what would you choose? Definitely 3? What would I choose? Still 3. Yes, you're right. So that's a clue which gives us positive information and some bit of negative information. In fact, the clue number 4 is also pretty similar. Vivian Young's films was first screened in 1937. She did not star with Buster Grant in his debut East Was Lost. That means there is one positive information and two negative information. What is the positive information? Vivian Young's film was in 37. Her male star is not Buster Grant, and her movie was not East Was Lost. Buster Grant's debut is East Was Lost. That can also be a positive statement to take. And his female star was not Vivian Young, and movie was not in 37. So that also a nice clue that we can work with. Both clue number 3 and clue number 4 has one positive and two negative information. The clue number 5 is again a positive information, but only one. The 1936 movie male star was Errol Cooper, and the last one, Pride, was not the last film. That's a negative information. We really don't like things like this, right? So among these clues, giving us maximum information is either clue number 3, clue number 4. Just because it's in order, I would choose the clue number 3. It's no marking that clue number 3 is the best. We don't know, but we ended up having only 2 clues to select from. So that is the ace clue. This is what we call the ace clue. So let's see. So we know John Keaton is a male star and Carol Harlow is a female star, right? Then we have a male star and we have a female star. So we have clue number 1, clue number 2, clue number 3, clue number 4, clue number 5, and clue number 6. So we have John Keaton, male star, and Carol Harlow, female star. Now there are 5 years of release. That's simple. That is 34, 35, 36, 37, and 38. And there are 5 movies here. There are 5 movies. What are the movie names? Captain Winchester, Destination Phoenix, East Was Lost, Pride, and The Floridian. Okay, there are 5 movies, right? So let's see what we can eliminate, what we can't eliminate. The Floridian didn't make its appearance 35-38. It did not star Cary Flynn, who wasn't Greta Lombard star. So you leave all that, right? Second statement is important because we've already mapped male star and female star. We're looking at movies and years. These are the movies and these are the years. So what are we talking? Destination Phoenix saw Jean Garbo. So Jean Garbo is a female star, and this female star acted in the movie Destination Phoenix. That means Carol Harlow, who is a female star, cannot act in the same movie Destination Phoenix. Are we okay with that? Okay. Okay, we go to the same statement. That's a clue number 3. John Keaton and Carol Harlow were the co-stars of the film released after Captain Winchester. That means the movie was definitely not Captain Winchester, and it was released after Captain Winchester. That means the movie cannot release in the year 34. Whatever movie that was, it has to be at least after one movie. So it cannot be 34, it has to be at least 35. Vivian Young's film was screened in 37. Now, Vivian Young is a female star. Her movie was released in 37, right? That means we cannot have 37 here because Carol Harlow is a female star. We cannot have two female stars in the same movie taking the lead role. Alright? Next, in the same statement, that's a clue number 4, you'll notice that Buster Grant, she did not star with Buster Grant in his debut East Was Lost, which means Buster Grant's debut was East Was Lost, which means male star is Buster Grant, debut East Was Lost is ruled out. Right? Okay, simple one. The 1936 release starred Errol Cooper. That's a clue number 5. But Errol Cooper is a male star, so we cannot have 1936 here. We're left with 35 and 38. And the movie we're left with, Pride and The Floridian. You'll notice if you come back to the clue number 1, the Floridian didn't make its appearance in 35 or 38. That means this cannot be the Floridian. It has to be Pride. And the last statement says Pride was not the last movie, so it cannot be 38, it has to be 35. So the ace clue has given us, this is the best clue. Why? It's given us one full set. It's given us the name of the movie, it's given the male star, it's given the female star, and it's given the year. Now, is it necessary that it has to give in the first time you do it? No. It might be possible that the clue number 3 might not have given the full information. Maybe the clue number 4 would have given that. That would have become the better clue. Right? Are we okay with this? So we know 1934 saw the male star as John Keaton, right? The John Keaton was a male star. The female star was Carol Harlow. So let me just write it here. We know that. Okay, so what I'll do is I will write the male star and female star at the top, because otherwise it will map with and you'll see the space required for this is much. Yeah, what I forgot to tell you is this grid method takes a lot of space as well, right? But here you see the space is very little and we still were able to do it within the given space, right? So here let's map it. Let's quickly map it. So what I'll do is male star, female star, I'm writing it at the top, right? 34 male star is John Keaton and Carol Harlow. That's a male star at the top, female star here, and movie name I'll write it at the bottom. John Keaton, Carol Harlow, and the name of the movie is Pride. 1935. 1935 saw John Keaton, Carol Harlow, and the name of the movie is Pride. But we know John Keaton and Carol Harlow were co-stars of the film released the year after Captain Winchester. That means the movie before 1935 was Captain Winchester for sure, right? And 1936 movie, the male star was Errol Cooper, given data, right? Vivian Young's film, that's clue number 4, was starred in 37. Whatever we are able to fit, we'll try to fit it off first. Vivian Young's film was released in the year 37. Now we have extra data and we have those positive data. 1. Buster Grant's debut was East was Lost. That's some good data we have. Second data we have Carrie Flynn. Okay, this is negative information though. Did not star with Greta Lombard. And we have another information. We have another information here, right? That is Destination Phoenix saw Jean Garbo. That is female star movie. That is Carrie Flynn, male star, female star. That is female star movie and male star movie. Right? Okay. Superb, simple one. Now we got to map. We got to map this data. Buster Grant East was lost. Now where do you think we can place Buster Grant and East was lost? Right? Buster Grant is a male star. Right? Buster Grant can come in the year 34, not possible because East was Lost is not the movie, it's Captain Winchester. Buster Grant, can it come in the year 35? No, because John Keaton is already a male star. 36, not allowed because Errol Cooper is already a male star. 37, not allowed. Why? Because Vivian Young cannot act with Buster Grant, which means Buster Grant has to come in the year 38, and the movie in 38 was East was Lost. That's damn simple. There's a female star, will fit the female star in a while, nothing to worry. We also have Destination Phoenix or Jean Garbo. So Destination Phoenix is the name of a movie and the female star is Jean Garbo. That makes a lot of sense because Destination Phoenix can either come in 36 or 37. There are only two blanks. 37 cannot be the value for, what do you say, Destination Phoenix, because Destination Phoenix cannot be in the year 37 because the female star in 37 is already decided, right? So simple one. So we have Destination Phoenix in 36 and the female star is Jean Garbo. Superb. There's only one movie to go. There is a Floridian. So Vivian Young acted in the movie The Floridian. We also have some more data to fit. One, the The clue number 1, the Floridian didn't make its appearance in 35 or 38. It did not star Carrie Flynn. The Floridian did not star Carrie Flynn. Male star Carrie Flynn has to be in 34. There's only one space left. There's one male star left. The name of the male star is, I think, Gary Wayne. That has to be in the year 37. And Carrie Flynn did not star with Greta Lombard, so 1934 cannot be Greta Lombard. Greta Lombard has to be 38. So only one female star. The name of the female star in question is Loretta Lee. So you see the size of data that we have mapped that big data, no table, into a very small looking table. That's how much less amount of space you require for this method. That's why it's called the ACE clue method. The ACE. Okay. So you take the data and we will be able to do the entire thing. Very common in XAT type, this level of difficulty, right? It's a pretty high level difficulty, guys. Let me also let you know, right? But we did it in very less space to identify. Why? The main thing was this, right? Less amount of information we used, right? The Vivian Young starred in the movie. That's pretty simple. That is the Floridian, right? Here you can see Vivian Young acted in the movie The Floridian. Next one, John Keaton's film was released in which year? So John Keaton's release was year 35. Okay, and Captain Winchester was released. So Captain Winchester was released in the year 34. That's 1 year before. 1 year before. What do you call? John Keaton and Carol Hallows movie. The movie released in the year 37. That was The Floridian. Pretty simple once you know this, right? So that's it for now. Thank you. Thank you. I hope we had some thinking process. Thank you for being with me. And, we can definitely continue with this association. I'm looking forward to meet you and I'm looking forward to change the way you think on LR and DI. Right. Thank you all for your active participation and support. You have a good day and a great preparation. Happy learning to each one of you. Thank you very much.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.